Hey, and welcome back to Blockchain, Cryptocurrencies, and Web3 Foundations, Module 6. This week we'll be talking about blockchain in real-world applications. So, much like every week, I think it's important to go ahead and get something to write on so we can take some notes that'll be important in the class discussions. All right, so we've talked a lot about blockchains kind of in the abstract, and we've had some more concrete things that have come up in the class discussions and previously when we're talking about specific blockchains. Because in general, you'll get a lot of people confused with the blockchain, thinking that overarchingly there is one system out there that does all this and coordinates all it, or there can only really be one kind of blockchain. Right? And really, there are many blockchain choices. Fundamentally, the Bitcoin is the granddaddy, so to speak. It's been around the longest here, and specifically is the forefather of all cryptocurrencies. So that's one option. We'll get into why you might not want to use Bitcoin specifically in the end, though. In Ethereum, we've talked about some in the class discussions and some of the readings, and various clones in terms of people who have forked Ethereum and are doing things alongside of it. This also happens with Bitcoin, but more prominently, at least in recent times, Ethereum is the thing that people are trying to copy and spin up their own networks of in various forms. But there are plenty more. Polkadot is a great example. Stellar is another one. Solana and Neo, and really Hyperledger Fabric, and so many more. The list goes on in terms of your options. And so it can be a little bit daunting if we're trying to really put together a blockchain application. Which blockchain should we use? Do we even need to make our own blockchain? Like what should we do to go forward? And when we start this kind of process, when we're digging into what we should use in general, this decentralized computing services triangle comes up, this DCS. So specifically here, there's really a trade-off between three things. You pick two, as they say. You can land anywhere on this area of the triangle. And you have to fight constantly between planetary scale, so how large the system is going to be, how encompassing, and really that means that we have to deal with a lot of latency. So how long it takes to propagate information throughout the system, it comes into account. And then consistency. And this is kind of the other end of the spectrum, is that if every node on this network needs to have the same information at the same time, or at least very close to it, we have some trade-offs to make with that scale. And fully decentralized. So really, who's in control of this and who can administrate and add new nodes and whatnot. In a highly permissioned system where everyone is known, the latency and the throughput can really be the latency can be pushed down, the throughput can really be pushed up, but we're trading off this idea of decentralization where it's permissionless at the very least. So this is something to keep in mind, that basically every blockchain is trying to fit somewhere on this this triangle here to fit your particular needs. Right? So moving forward then, if we're trying to assess which blockchain should I use specifically, there are plenty of different qualifications that we can put into this. And most notably, people talk about transactions per second. That is effectively how much throughput globally on this network are we enabled to be able to make happen. But that is a bit of a misnomer, and it's really talking about base transactions in terms of sending cryptocurrency typically. So the fundamental thing you can do on the network, how much of that can you do in 1 second? Whereas we're talking about smart contracting platforms like Ethereum, there's this concept of gas, which I think you might have seen in the readings thus far, that really varies in terms of how many smart contract transactions can actually happen, because those can be much more complex and thus take more of the bandwidth of the network at any given time. So then looking at this, you might want to have some permissioned and authorized systems. Some of these are built for that, some of them are not. And then how much privacy is there in terms of who gets to see information at all, and then also if the information is available to people, is it encrypted, is it masked in some way? And all of these things are really important baseline metrics to kind of get a sense of where you might want to sit. And of course, smart contracts in particular are the thing that most people are most interested in. Bitcoin in particular is devoid of smart contracts. It doesn't understand how to do these things. If you really get into the technicals, it does. Bitcoin has a SIG script in terms of being able to write simple programs. They're stack-based programs. So If you're familiar with computer science, this is very low level in terms of being able to interact with this stuff. And it is not Turing complete in the sense I can't write any arbitrary program. I only have a few different operations that I can instruct Bitcoin to run. So there are some platforms like RSK is one that comes to mind that do develop smart contracts on top of Bitcoin. But those are, at least at the time of writing, not very prevalent compared to more Turing complete, abstract, and mostly Solidity based targeting Ethereum smart contracts. And Solidity seems to be the language in which everybody wants to write these smart contracts in presently. That may not always be the case, but it was specifically made for the Ethereum ecosystem, and many other ecosystems now support them. I believe Solana and Hyperledger Fabric, as well as Polkadot, in terms of the derivations that come out of Polkadot, can support some of these things. And then if you have some native asset that really makes it a cryptocurrency-based blockchain, you can do it without this, right? And it does depend specifically on your use case. You need other mitigation factors in some way, which might lead to more permissioned and private network to make sure that there's no DOSing, meaning distributed network attacks on these guys. So lots of things to factor in. And then finally, if there are coins here, how much does a transaction cost? Again, that gets convoluted in terms of smart contracts because those can be more expensive based on this concept of gas, but something to consider. So that's kind of just scratching the surface, but it gives you a sense of kind of the grid you might want to set up in some of these qualitative as well as quantitative metrics that you can use to figure out if there's a network that fits your specific use case. And if there's not, then you might need to make one of these things. But now let's say you've decided on which blockchain you want to run or which blockchain you'd like to build, right? Now, where do you run this thing? Where do you operate this? If you have to operate a blockchain itself versus running an application that talks to a blockchain, one of these dApps that we've looked at previously, you can run your own infrastructure. It's definitely the hard way and is very infrequently done in this industry. But that is primarily because I think we've lost the ability for many startups to really get the capital and the talent needed to scale and run all of these things themselves. So you need specialists that understand the security of the hardware that you're running on, how to maintain and update them and all this, as well as automation to make these systems work, similar to what people are much more used to, which is this cloud environment. So blockchain as a service is the easy way for sure. But it does come at a price, as we've alluded to previously in this class. Who owns and operates or secures your node can be a very important factor, especially when you're thinking about who should have access. And if that information is very sensitive and potentially someone might want to tamper with it, your provider might be one of the people you need to think of as an adversary potentially. Right? So this "not your keys, not your coins" mantra comes back up. And really here, you have to be keeping in mind that censorship is definitely a possibility, as well as potentially outright infiltration into your systems by parties that you're not necessarily wanting to be there. So yes, it's definitely the way that most people go, but understanding the risks that come with that, I think, is definitely worthwhile at looking at. So in the DU Wiki, which we'll talk a little bit about further on, it's a good place to look at some of the cloud providers and blockchain as a service providers that you might consider. And that list definitely should get some love from you guys to update and to include good resources as you find them. So now, like, if we've decided on a provider, it could be ourselves, right? It could be this cloud. Who do we trust and how do we trust them? And more than just this provider, how do we trust necessarily the blockchain in which all this resides on, right? Because these aren't all the same network. They have very different security guarantees that we can definitely investigate, right? Blockchains, they really are trust machines in the sense that the machine, though, might be compromised. So the protocols in which are running throughout the network presumably are going to catch if any of the other nodes are going to be acting poorly, right? Acting adversarially. But the machine that you're running your node on might not be. So here it's very important to assess what your interface with this network is, because that machine itself might be corrupted, whether you host it yourself or a cloud provider does. And then really, if we're selecting products and services to run within our blockchain infrastructure here, is what data could be compromised and what processes could be hacked into, right? Again, thinking if the protocol is safe, presumably, hopefully, what interactions do you have with that could potentially be manipulated and somehow lie to you about what the rest of the network is saying, right? The industry is definitely changing, and it is really full of opportunistic exploitation. So people who are looking for the easy way to get into this industry can often be caught up in very overpriced and honestly potentially outright scams when we're talking about using these systems, right? Whether it's getting into some cryptocurrency related scam or a cryptocurrency service provider scam, something to consider, okay? So then who can I really trust for information? Because getting signal to noise here can be really difficult. Blockchains are extremely complex. And it leads to really unintentional, but also malicious use of these misunderstandings to try and get people to ape into whatever it might be, right? So when we're trying to get this filter, even experts can be fooled, right? And honestly, some of the information can change over time in terms of what is the actual capabilities of whatever these systems are. They're all growing and evolving rapidly. The things that I knew a few years ago are completely turned on their heads in terms of what the capabilities are even on the same network. So it's really important that we get these good sources of information. So if we're going to be finding this, especially new, up-to-date stuff, I've found that actually podcasts, depending on the quality of podcasts and which ones there are, we can get some true experts in the field that can distill this information down pretty well and be not necessarily your source material, but point to great references that you can use. And the course wiki has some of these listed in terms of the podcasts that I would suggest. In the show notes, typically, they any of the ones that I respect have a lot of good information to link you out. So it uses a base to start doing lateral reading and discovery of other resources. And then conferences, live or recorded. In the time of COVID here in 2020, we have a lot of online events that are going on that really are quite solid in terms of being up to date with information. But when these are in person, they usually are established and recurring yearly events, can be really great places, not only to learn, but to network with this industry. And you get exposure to some of these bleeding edge products and services. Are all of these quality? Not necessarily. But there is some filter here that you can look to get from the attendees, especially the higher quality people who are there working in the industry, to assess what these products and services that are being marketed to you at these places are. And also a great place to just learn about what the industry players are doing presently, right? And then publications, formal or informal. There are quite a few people, especially in the Ethereum space, that don't really have a formal academic credential and aren't publishing in formal journals and things like this. So we see a lot of stuff happening in blogs and white papers that go out in unestablished, like Medium or something like this, or Stack Exchange, are definitely mediums in which you'll find very good information if you know where to look. But as opposed to more typically in academic circles where journals that are peer reviewed, you might find some of this stuff. That is not devoid in this industry, though. Especially when it comes to the cryptography, you'll find many more studies and papers that do come more into the purview of academics. So depending on which aspects you're trying to evaluate, that is a good place to go. And then there are some books. Again, this course wiki does have a listing. And if that's something that you pursue in this space, they typically aren't bleeding edge because it takes a while to develop these books and then get them published and put out to the world. So for fundamental stuff and understanding generalities, these are great, but not necessarily for understanding what's the most important things to get your application up and running. And then specifically to DU here, we have a shared open source wiki. And this is part of the assignment this week that you'll be contributing to, as well as there's a DU Crypto Club. In the slides here, there's a link to join their Discord if you'd like to get to know some of the other people who are in this industry actively, alumni as well as present students who are interested in blockchain. So I encourage you to go and check that out. And then specifically, because we're here in Colorado, most of us, Colorado really does have a lot going on in the blockchain industry. So whether you're here in the state, it is pretty exciting times. We have a large community here that we would love to have you come out. Cryptorado is something that I've been running for a few years here. And this is specifically centered around weekly to bi-weekly meetups. And it's really a very active community of people who are interested in all different areas of this industry. And cryptocurrency in general in Colorado has some very major legal and regulatory stuff that are going on here in a very positive light. The Digital Token Act came out just a few years ago. It was one of the first of its kind to give specific guidelines around what qualifies and what does not qualify as a security when you're selling a token. And this was pioneered by the Colorado's Council for the Advancement of Blockchain Technology. So this council was put together, I believe, in 2017, 2018 time range, and developed this Token Act as well as some other stuff. And some of those echo to this day in terms of proactive stuff that's going on within our industry here in Colorado. And there's also in the slides, there's a list of blockchain companies that exist here in Colorado. If you're interested, go and check it out. It may or may not be up to date, but it's contributed by people who are here in the community to try and make sure that everyone's aware of who's here locally working in this industry. And then to continue that, the leaders here are really some interesting people. Jared Polis is a very active advocate of this stuff. Talking about conferences, the Ethereum Denver is one of the largest conferences that goes on in the world around Ethereum, and he's appeared here and been very proactive here. And it's pretty exciting to see. We also have the Securities Commissioner, who is a former Ethereum Council member, and this is really interesting to see her perspectives on how we should be running the securities side of what we're doing here, specifically with blockchain technologies like Ethereum. And we also have a dedicated blockchain solutions architect here in the state. That's Thad Matt. We do have proactive involvement from the state at trying to incorporate blockchain solutions into what we do at the governmental level, not just what we should do with regulatory and legal stuff here. So there's also really some interesting pilot programs that are going on, and I won't elaborate on these too much, but if you're interested, come into the slides and check these out, pioneering works that are going on right now in the state. And as I was saying, Cryptorado is this great group I would really encourage you to come and join us, whether or not you're in Colorado. If you ever plan and visit, we do a lot of things locally, but we also have this online community that you can get access to through cryptorado.org. So come and join us there, and this is a great place to continue after this class is done if you'd like to get involved here in the local scene. And that's it for Module 6. So we explored some local resources that we can tap into, as well as some of the trusted sources for news and information you'll find in that course wiki, and a few that are noted here in the slides if you'd like to come and check out those links. Next module, we would have a guest lecture, but we're going to switch things up. So we'll address some more details of holistic Web3. Now that we understand a lot more about blockchains, how do we put this together with other systems to make a really interesting application more than just a blockchain? All right, thanks, guys.